Hi everyone, welcome to Mathly. Today we are diving into random forest, one of the most powerful and widely used machine learning algorithms. Whether you're classifying data or making predictions, random forest delivers accurate results while being surprisingly easy to use. If you are new to tree-based models, I recommend watching our previous video on decision trees to understand the basics. But for now, let's explore the random forest. And the best part, we'll explore it visually using the Orange data mining software. Let's get started. Imagine you're trying to decide whether it's a good day for a picnic based on factors such as weather forecast, temperature, and wind speed. Instead of relying on just one weather app, which could be inaccurate, you ask multiple apps for their predictions. Some might say, yes, it's a good day, while others might say, no. You then go with the majority opinion to make your final decision. This is similar to how random forests work. Instead of relying on just one decision tree, it creates many trees, each making its own prediction based on random parts of the data. For example, one tree might prioritize wind speed, another might focus on temperature, and another on the chance of rain. By combining the predictions of all these trees, random forest gives you a more reliable and accurate result. Random forest is like having a team of experts instead of just one. Random forest is like building a team of decision makers to improve the accuracy of predictions. Here's how it works. First, random forest creates multiple decision trees, but each tree is slightly different. To ensure diversity, the algorithm uses two techniques: bootstrap sampling and feature randomness. In bootstrap sampling, each tree is trained on a random subset of the dataset, where some samples may appear more than once and others not at all. And feature randomness ensures that each tree only considers a random subset of features for splitting the data at each node. When it's time to make a prediction, random forest aggregates the results from all the trees. For classification tasks, it takes a majority vote. If most trees predict yes, the final prediction is yes. For regression tasks, it averages the outputs of all the trees. This process is powerful because it reduces overfitting. While individual trees might overfit to their training data, combining their predictions smooths out the noise and produces more accurate and generalizable results. So, random forest isn't just a single model. It's an ensemble of trees working together to provide reliable predictions, making it a go-to algorithm for both classification and regression tasks in machine learning. Now, let's move into Orange software, and in this video, we will be using the Employee Attrition dataset throughout the demonstration. This dataset is widely used in data science for its effectiveness in explaining these concepts. So, I've loaded the Employee Attrition dataset using the Datasets widget. Employee attrition refers to the loss of employees from an organization, whether through resignation, layoffs, or retirement. After loading the dataset, I have used the Data Table widget to inspect the raw data. This widget allows us to view the individual features and values for each employee. This dataset contains 32 features such as age, department, education, gender, and more. And it also has a total of 1,470 instances. Next, I have used the tree widget to create a decision tree model. A decision tree essentially splits the data into branches based on the most important features. To visualize the tree, I have added the tree weaver. As you can see, the generated tree is gigantic, with numerous splits and branches. While this level of detail is helpful for understanding the exact decision-making process, it can also be overwhelming to interpret visually. To weave the tree in a simpler and more intuitive way, I have used the Pythagorean tree widget. So this widget provides a compact, block-based representation of the tree, making it easier to understand its structure and decisions. For example, if I hover over the base block, as you can see, it has split the data by the feature over time. Like that, you can see how decisions are split at each step in a much clearer way. While a single decision tree is great for understanding how the data splits, it can sometimes overfit or be too simplistic. So, I have added the random forest widget. A random forest is basically a collection of multiple decision trees. In this case, it builds 15 trees. And to visualize the trees, I have added the Pythagorean forest widget. This widget shows me all the trees in the forest in one compact view. As you can see, each tree is different, which helps improve the overall prediction accuracy. Finally, I have used the test and score widget to compare the performance of the single decision tree and the random forest. This widget gives me a variety of metrics like area under the curve, classification accuracy, F1 score, and more. As expected, the random forest has performed better than the single decision tree across all these metrics. This is because it combines multiple trees, each trained on different subsets of the data. By voting on the predictions, it reduces errors and makes the final prediction more reliable. Essentially, the more trees, the more accurate and stable the prediction becomes. This process helps to avoid overfitting, leading to better overall performance. Random forests are used in many real-world applications because of their ability to handle complex datasets and make accurate predictions. For example, in healthcare, they are used for predicting diseases like cancer by analyzing medical records and test results. In finance, random forests help in credit scoring and fraud detection by identifying patterns in transaction data. They are also widely used in marketing to predict customer behavior, segment audiences, and optimize campaigns. Also, they are applied in environmental science for tasks like predicting climate changes and analyzing deforestation patterns. The versatility and accuracy of random forests make them a powerful tool in various industries. And that is a wrap on random forest, a simple yet powerful algorithm for tackling complex machine learning problems and real-world challenges. I hope this video gave you a clear understanding of what random forest is and how it works. If you found this video helpful, don't forget to like, share and subscribe to Mathly for more data science tutorials. Comment below with what you would like to learn next. Thank you for watching and see you next time.